right, good morning, everybody. Today is Thursday, August 3rd, 2017, and this is Before the First Cup with Jules here on UCY.TV. Happy Thursday, everyone. It is a partly sunny 72 degrees and a very lovely summer day here in upstate New York. So where do we leave off on Tuesday? We titled the show U.S. CRISPR'd Embryos, Electric Food, and CO2 Millionaires. We talked about a lot of things. We talked about them finding a way, all in the name of climate change, to suck the CO2 out of the air and turn it into some sort of carbon nanowire wool at $600 a ton that they can make $100,000 to $400,000 a ton on. But I was calling bullshit on CO2 being a real climate change gas because we have things such as methane and other ways that our environment are being polluted. And it was Bill Gates who had come out originally and told everyone at a TED Talk a few years back that we need to get the carbon quotient down to zero. Well, interestingly enough, I don't know if Drew Lamb, if you guys remember Drew and Chuck used to do a show here, if Drew listened to the show or not, but he posted a story today. I wasn't going to continue on carbon dioxide today, but this was pretty interesting. So we found out they can make millions on CO2 emissions. Bill Gates also released a formula. I hate when videos play when I launch a web page because sometimes that's what takes my browser down. Bill Gates released a formula for how to save the planet quite a number of years back, and that was P times S times E times C equals CO2, which is our carbon dioxide output. According to Forbes.com, it is a neat little formula because it drives home the point that for all the Paris climate talks and more affordable Tesla cars you have out there, environmental incrementalism is somewhat pointless in this equation, which was Bill Gates. P equals population, S equals service, E equals energy needed to power those services, and C equals the carbon dioxide created by that energy. And with population, of course, trending even higher, as are the services that people are demanding, especially in the developing world, which has barely scratched the surface with cars and air conditioning. Those two factors swamp progress in energy efficiency. Bill Gates points out that scientists are calling for an 80% drop in carbon emissions by 2050. But hey, if you can't drop it, then why don't we just suck it out of the atmosphere and use it to make bazillions with a total end of carbon output by the year 2100? That's not too far away, guys. To stave off the most dramatic effects of climate change, yet with even more efficiency, the growth in population and services means that emissions will instead jump by 50% if we continue on our current trajectory. Math 101, the only way to get to zero carbon dioxide output is to drop one of those inputs to zero. And since eliminating any carbon byproduct of energy is preferable to a complete human die-off, ding, or a Stone Age suite of services, that would be the only path. So rich guys getting richer is all in your best interest there. We're just going to suck something that is necessary for green plant life on Earth and make billions out of it, and you won't know any better. Unless emissions get to zero, says Gates, you are just not going to get there. So now let's fast forward a little bit. Bing, bing, bing. And we're going to find out that Billy Gates, when was this dated? I hate not being able to find a date. Billy Gates has a new technology that he has funded that turns CO2 into fuel. Hey, scientists in Canada are developing an industrial carbon dioxide recycling plant that could one day suck CO2 out of the atmosphere and convert it into a zero carbon e-diesel fuel. Developed by tech startup called Carbon Engineering, The system will essentially do the job of trees, those pesky trees. Wait a minute. I had mentioned that we'd run across a story a while back where even though plants utilize carbon dioxide, so why don't we plant more plants to suck up all the extra carbon dioxide? We ran across a story a while ago that said more green actually contributes to global warming. So anyway, so this will essentially do the job of trees, but in places unable to host trees, such as icy plains and deserts. Carbon engineering is partly funded by Bill Gates, and Gates has stated that he plans to double his personal investment in the innovative green technologies to $2 billion over the next 5 years in an attempt to, quote-unquote, bend the curve in the fight against climate change. The CO2 recycling plant will combine carbon dioxide with hydrogen split from water to form hydrocarbon fuel. And the plan is to provide the technology that could one day produce environmentally friendly, ding-a-ling, keywords, to complement the renewable energy systems we have now. How do you power global transportation in 20 years in a way that is carbon neutral? Jeff Holmes, business development manager at Carbon Engineering, told Mark Gunther at The Guardian, quote, cheap solar and wind are great at reducing emissions from electricity, and then you are left with the transport sector. Carbon Engineering is one of a handful of companies around the world that are now set on coming up with ways to suck enough carbon dioxide out of the atmosphere to actually put a dent in the effects of climate change. And to actually make CO2 scarce, so you're going to have to pay for it. That's what I am predicting. There's also the New York City-based startup called Global Thermostat. That's a pretty good name. And a Swiss-based Climeworks, which demonstrated earlier this year with Audi how technology that can capture carbon dioxide and deliver it to a German company called Sunfire, where it was recycled into a zero-carbon diesel fuel. While Climeworks' demonstration was impressive, what all three companies now need to do is figure out how to make their atmospheric carbon dioxide to fuel systems economically viable. And this won't be easy, but hey, we read about a company that is using solar power to convert carbon dioxide into these carbon nanotube wool at a cost of $660 a ton, and then sell it for $100,000 to $400,000 a ton. Cha-ching! So don't worry about that. And they're going to put those all over the ocean. So anyway, right now, Carbon Engineering's plant system can only capture about 450 metric tons of CO2 a year, which would barely cover the carbon emissions of 33 average Canadian people. But they say that the system could be scaled up to 20,000 times to make it more practical. And as the video above explains, direct air capture seems to be the only potentially feasible way to absorb carbon dioxide that has already been emitted from small mobile sources such as cars, trucks, and planes, which of course it's all your fault, which make up 60% of the carbon dioxide emissions today. The systems require 1,000 times less land than carbon-sucking trees. Oh, so trees now are taking up too much land. Not a good solution. Do you guys see like how twisted this is? Like they're really trying to turn your thoughts against nature as being the solution. The nature that we've destroyed, the rainforest that we've cut down. We're all pesky and taking up precious, precious space on the planet. I mean, it's just beyond unbelievable. Don't let them fool you with their gobbledygook. So, there was a story out of Scientific American, came out in 2007. More trees, less global warming. Right? Well, for dummies like Joel, not exactly. We ran a 150-year simulation of worldwide deforestation, and it found that tropical forests are carbon sinks, but boreal forests contribute to global warming. So before compact fluorescent light bulbs and ethanol, The first line of defense against global warming was planting trees. Forests, after all, cool the atmosphere by drinking carbon dioxide from the air. But a new study, however, published in the Proceedings of the National Academy of Sciences reports that forests and other climatic effects can cancel out carbon cleaning advantages in some parts of the world. Using a three-dimensional climate model, the research team mimicked full global deforestation. Oh, that's nice. And also studied the effects of clear cutting in different regions of latitude, such as the tropics and the boreal zones. And apparently, these natural carbon sinks only do their job effectively in tropical regions. So the rainforest, cutting them down is a bad idea, in other words. In other areas, they have either no impact or actually contribute to global warming, the planet. And in fact, according to this model, by the year 2100, which happens to be the same one that Billy Gates was aiming for, if all the forests were cut and left to rot, the annual global mean temperature would decrease by more than 0.5 degrees Fahrenheit. So let's cut them all down in the name of climate change. How horrifying is this study? And this is out of Scientific American, no less. I am not sure that the slight amount of cooling is necessarily significant, but that removing all the forests produce little change on temperature is, says study co-author Ken Caldera, who is an ecologist at Carnegie's Institution of Washington's Department of Global Energy in Stanford, California. I've heard Ken Caldera's name negatively mentioned before, and I think that was by Dane Wigington. So Ken Caldera says, well, if we cut down all the trees, it's not going to make that much of a difference. I think what is interesting is this global cancellation was a product of very different responses at different latitudes. Trees perform three major climate functions. They absorb carbon, which they pull from the atmosphere. They create a cooling effect, and their dark green leaves absorb light from the sun, which heats Earth's surface. And they draw water from the soil, which evaporates into the atmosphere, creating low clouds that reflect the sun's hot rays. And these three factors, the second two being largely ignored in climate models up to this point, according to Caldera, taken together create very different results in primary latitude studied. The equatorial tropic zones, the mid-latitudes that include most of the U.S., and the boreal zones, which are subarctic and include much of Canada, Russia, and the northern extremities of the U.S. In all three regions, forests dutifully performed their task of sucking carbon dioxide from the air, but light absorption and evotranspiration, which is evaporating water, vary widely. In tropical zones, forests have a significant overall cooling effect. The soil is very wet, and so via evotranspiration, the trees are covered by low-lying clouds that create a small albedo, which is a power of light that is reflected by a surface. In non-tropical areas, the significant factor is whether there's snow on the ground in winter. If a forest covers a snowy expanse, that is a strong warming influence, he notes, because little cloud cover resulting from less efficiency in evaporating water. The poor cloud formation coupled with the intense absorption of light by the trees far overwhelms the cooling influence of the carbon storage, he says. So where does that take us? Well, there was a story actually published out of news.com.au out of Australia. Drew Lamb published this yesterday. Perth electrical engineers' discovery will change the climate change debate. Now, remember I was talking about them discussing for many years that we were in a global cooling period before they did that full recalculation of all of history's climate data a few years ago, just before the COP21 conference. Well, a mathematical discovery by Perth-based electrical engineer Dr. David Evans may change everything about the climate debate on the eve of the UN Climate Change Conference in Paris next month. And this story was October 5th, 2015. and I don't remember reading this actual story, but I have read about some of his theories before. This is one of the reasons why I was calling bullshit on Tuesday. A former climate modeler for the government's Australian greenhouse office with 6 degrees in applied mathematics, so he is a smarty pants. Dr. Evans has unpacked the architecture of the basic climate model, which underpins all climate science. He has found that while the underlying physics of the model is correct, it actually has been applied incorrectly, and he has fixed 2 errors, and the newly corrected model finds that the climate sensitivity to carbon dioxide is much lower than was thought. Ding-a-ling. Like I was saying, carbon dioxide isn't the worst greenhouse gas. I would have to say it would be something like methane that is coming out of the melting permafrost at the bottom of the oceans and potentially up in those boreal regions. It turns out that the UN's Intergovernmental Panel on Climate Change has overestimated future global warming by as much as 10 times, he says. So let's sound the alarms, let's make bazillions, and let's restrict everything the global population can do, and let's use some of these new technologies to be able to rob the environment of resources that should belong to everyone on the globe and crack down on personal freedoms, all in the name of trying to control a natural gas that fuels life on planet Earth. Yes, CO2 does have an effect, but it is about a fifth or a tenth of what the IPCC says it is. CO2 is not driving the climate. It caused less than 20% of the global warming of the last few decades. Dr. Evans says that his discovery, quote, ought to change the world, unquote. But the political obstacles are massive, he says, and his discovery explains why none of the climate models used by the IPCC reflect the evidence of recorded temperatures. The models have failed to predict the pause in global warming, ding ding, which has been going on for 18 years and counting. And that's what I was talking about, just that whole thing about we were moving into global cooling and a mini ice age potentially in the future. It's what the mantra had been up until just very recently. The model architecture was wrong, he says, and carbon dioxide causes only minor warming. The climate is largely driven by factors outside of our control. And there is another problem with the original climate model, which has been around since 1896. While climate scientists have been predicting since the 1990s that changes in the temperature will follow changes in carbon dioxide, the records of over past 500,000 years now show that that is not the case. Until, of course, they change them all. So the new and improved climate model shows CO2 is not the culprit in recent global warming. But what is, he asks? Well, his theory states solar activity, ding ding, and that is what I mentioned yesterday, what he calls albedo modulation, which is the waxing and the waning of reflected radiation from the sun, is likely the cause of global warming. He predicts global temperatures, which have plateaued, will begin now to cool significantly between the years of 2017 and 2021. But hey, if that's not going to happen naturally, let's just fire up those atmospheric heaters and heat things up so we can point to that and say, look, it is warming, and look how messed up the global weather patterns have become. I'm telling you guys, and somewhere in here, oh, here it is. I found a study about the upper atmosphere. So anyway, he predicts they'll begin to cool significantly between 2017 and 2021, but if that doesn't happen, we'll have to help that out. The cooling will be about 0.3 degrees Celsius in the 2020s, and some scientists have even forecast a mini ice age in the 2030s. If Dr. Evans is correct, then he has proven the theory on carbon dioxide wrong and blown a hole in climate alarmism. And let's go back to his credentials. He actually was a former climate modeler in the Australian government's greenhouse office with 6 degrees in applied mathematics. So he is someone who apparently has some clout in what he is talking about. He will have explained why the doomsday predictions of climate scientists aren't reflected in our actual temperatures. It took me years to figure this out, but finally there is a potential resolution between the insistence of climate scientists that CO2 is a big problem and the empirical evidence that it doesn't have nearly as much effect as they are saying. Dr. Stevens is an expert in Fourier analysis and digital signal processing with a PhD and 2 master degrees from Stanford University in electrical engineering and a bachelor's degree of engineering for which he won the university medal and a Bachelor of Science and a Master in Applied Mathematics from the University of Sydney. He's been summarizing his results in a series of blog posts on his wife Jo Nova's blog for climate skeptics, and he is about halfway through his series with blog post 8 called Applying the Stefan Boltzmann Law to Earth, which was published on Friday in October of 2015. And when it is completed, his work will be published as 2 scientific papers. Both papers are now undergoing peer review. This is a new paradigm, he says, but it has several new ideas for people to get used to. So there you go. Cracks in the climate change debate appear. And I gotta say, it's very convenient that they are finding new ways to make millions of dollars on a gas that we all produce as a byproduct that is necessary for other life to prosper on Earth. So I found a paper on Tuesday titled Climate Change in the Upper Atmosphere. And this is when I was talking about those atmospheric heaters. I really should find that document because I've mentioned it so many times. This was a document that I found looking up HAARP and DARPA at the University of Alaska. We discovered that the new president of the University of Alaska was a former employee of DARPA. How interesting is that? And that was after DARPA took over the HAARP facility from something like the Air Force and did some experiments, then shut it down, and then handed it over to the University of Alaska at Fairbanks. But one of the things that we found in some of our research is that we have institutions like the Air Force where plasma bombing our upper atmosphere in order to fuel radio propagation. And this is where we started talking about some of the 5G technologies that are coming. I don't really know if I have enough 5G stuff up here today, but we'll try. But one of the things that they're doing is trying to propagate those radio signals. They're also using millimeter wave. We talked about that in the very beginning. I found that there were some new papers about that as well. That is how they're going to do it, to bolster the propagation of 5G. And a lot of this is very dangerous technology. We found there was a study out of Los Alamos Laboratory at one point that said that millimeter wave can actually, and that would be some of that terahertz radiation, can actually unzip DNA at the right frequencies. That doesn't seem to be too much of a concern for anyone right now. Don't worry about that, little Johnny. We have all this CRISPR technology going on that requires us to unzip DNA. Zip, zip. And some of these technologies are going to be beaming globally from the upper atmosphere. Could potentially, maybe accidentally or on purpose, do some of that same unzipping. Don't worry about that. Shh, go back to sleep. I don't know, guys. It just seems kind of suspicious to me. This is one of those eyebrow-raising moments when I've run across a few little tidbits in my reading that made me go, if I were a mad scientist, this could come in quite handy. But don't worry. All right, so anyway, this quote-unquote secret document I ran across, I did a couple searches, and I ran across a title. And when I clicked on it, it said, whoops, you need special super secret access and a password to be able to read this. but Google at one point had indexed it because it was public and saved it as cache. And if you click this little button down here, you'll be able to get access to it without a password. So I did that. Probably got my IP address on a list, but who cares? This was titled, it actually says on the top of the document, and I will link it because it's on my Google Drive. This is a Google cache of physicstoday.citation.org, and then gives a whole blurb of the document number. It is a snapshot of the page as it had appeared on January 29th, 2017 at 12:26:45 Greenwich Mean Time. The current page could have changed in the meantime, but don't worry about that because we'll show you what they published originally. It says out of physicstoday.citation.org, geoscientists, this is the title, seek to save HAARP. This is the American Institute of Physics. With ionospheric modification, scientists can do plasma physics experiments that are impossible in the lab. Well, phew. Good thing. Remember, I mentioned they were talking about how to turn our actual environment into a laboratory. Well, that is what they are doing. And I'm going to have to say that if you made me a betting woman, that I would guess that this had something to do with our quote-unquote climate change. Prospects for the continued operation of the U.S. High-Frequency Active Oral Research Program, more affectionately known as HAARP, became dire last June when its owner, the Air Force Research Laboratory, switched off its lights. And that was in collaboration with DARPA. HAARP is the world's most powerful high-frequency transmitter, and a few experiments are planned this spring by the Defense Advanced Research Projects Agency, more affectionately known as DARPA. If no one pulls a rabbit out of the hat, that will probably be the end, says David Heisel, a Cornell University atmospheric scientist who's part of DARPA's HAARP collaboration. Remember, I told you in further research, I discovered that a former DARPA employee has taken over as president of the Alaskan University of Fairbanks that is now running the HAARP facility. The High Frequency Active Oral Research Program in Alaska is the world's leading ionospheric heater, and with it, the ionosphere can become a plasma physics laboratory. That one just really gets me because they're turning our environment into a laboratory. Guys, these unethical experiments that are going on, and not just on our environments, but on humans as well, never ended. And they've been going on throughout all of the evil history that I've been able to trace back, at least for the 20th century, in all the name of keeping you safe. On February 26th, and I would assume that would be 2016, because this was from January of 2017, the White House Office of Science and Technology hosted a meeting for federal agencies to consider HAARP's future, and representatives attended from the DoD, NASA, the National Science Foundation, and Los Alamos National Laboratory. Ding! The aim was for the agencies jointly to either seek a solution to keep HAARP open or purposefully shut it rather than let the Air Force Research Laboratory kill it alone. HAARP cost nearly $300 million to build. Keeping it open hinges on someone coughing up about $5 million a year in operating costs. The meeting was private, but by the next day, word was out, no rabbit, but maybe a fighting chance. The U.S. Air Force spokesman told Physics Today that no decision had been reached. But still, after being briefed by the Office of Science and Technology Policy, U.S. Air Force spokesman told Physics Today that the director of the Geophysical Institute at the University of Alaska Fairbanks came away hopeful. The guys were optimistic, and they may have 2 or 3 years to build a business case. McCoy is working to bring in funding from domestic and international sources. The HAARP facility consists of an array of 180 cross-dipole transmitters for heating the ionosphere, plus instruments for analyzing the response. Located in Gacona, Alaska, about 375 kilometers south of Fairbanks, the facility began operating at low power in 1993, but a full array was not completed until 2007. It transmits frequencies in the range of 2.8 to 10 megahertz and can pump 3.6 milliwatts up into the ionosphere. These signals can also be shaped. Now, guys, if you remember when we did a whole bunch of shows on frequencies and all the different things they can do with frequencies and some of the different research that they have been doing from way back in the days of the origins of Bell Labs, and that was in conjunction with the Department of Defense. This has got to be a little bit concerning that they got this large array of transmitters that they can shape signals and pump out large amounts of energy into the atmosphere for things such as research. Remember, even some of those weapons titled the Voice of God, we know that a lot of the DoD is focusing their attention on energy weapons right now. And it's not just us. It includes China and Russia. We covered those a couple different times. It's got to be concerning to every single one of us. You got to wonder when strange things happen or when large numbers of people, statistically speaking, that I know personally, things in the news, start having these weird clotting events, that's all I'm going to say, accidentally or on purpose, it's got to make you wonder if there are other things that could potentially be going on. We read about optical tweezers last Friday, which would allow them to take focused beams of light. Remember, light is energy. It's all waves. It's all frequencies. But being able to take these optical tweezers and bend things such as blood cells to then form things such as clots. I mean, I'm not going to say that it's possible, but I'm not going to say that it's impossible. Just because you can't see it or you can't prove it doesn't mean that it doesn't exist. And there are lots of things going on down deep, dark hallways financed by lots of different scary people that who we don't even know their names. All in the name of keeping you safe. All in the name of defense. All in the name of curing you. Guys, I just know that being in the middle of a lot of these technologies now I find myself in, and every time I go to an appointment, I see another name brand of one of these technologies that we've covered on the show. It just makes me say, yep. It's all possible now. So, okay, ionospheric heaters. And remember, this is from the super secret document that was now password protected that I'm reading from. Ionospheric heaters work like shortwave radios, explains Brent Isham of the Inter-American University in Puerto Rico, who has used HAARP and other high-frequency facilities. It is the same way that Voice of America, Radio Moscow, and Deutsche Welle work. So interesting they mentioned Voice of America. It's our State Department-sponsored radio transmission that we send to all other countries to try to Americanize them as propaganda. But in those cases, these signals bounce from the ionosphere to go from one continent to another. And it works a lot like AM radio, if I'm not mistaken, but it propagates much further. If we take exactly the same transmitters and we point them straight overhead instead of bounce them, instead of just reflecting, the waves interact non-linearly with the ionosphere. The simplest response of that ionosphere is heating, but with that high enough input, unprecedentedly high power with enough power input, the energy density more complicated interactions can be induced, and because HAARP can focus the unprecedented high-power densities, says State of Utah's Herbert Carlson, we see an entirely new, rich variety of effects. So let's get excited. The Earth's atmosphere is dilute, so things happen slowly, like climate change, whereby in the laboratory plasmas, things happen much faster. You can see before and after, but you can't see things while they happen like you can in the real laboratory in the ionosphere. In our ionosphere, things happen slowly enough to watch that it is changing, and slowly enough for us to report upon it. That's what I'm saying. And ultimately, says Cornell's Heisel, people are interested in ionospheric modification, ding-a-ling, because they are interested in, like I've said, radio wave propagation, and to facilitate or to disrupt communications, and of course to study basic plasma physics. Now, guys, if that doesn't lay it all up for you, I don't know what does. But the Office of Naval Research has used HAARP for studies in which very low frequency, or good old VLF, like we have talked about before, and that is the same frequency that your brain operates upon. And those are, consequently, the ocean-penetrating signals as well, are generated in the ionosphere to communicate with deep-sea submarines or your brain. The Air Force has looked at nudging high-energy electrons out of radiation belts as a means to lessen degradation of satellite electronics and disruptions in satellite communication due to solar activity or to nuclear explosions in the atmosphere. The facility, and that would be HAARP, has been used to explore other issues related to GPSs and satellite communication, and basic science at HAARP includes such efforts as sustaining high-density plasma layers and creating artificial aurora to learn more about wave plasma interactions. In addition, summer schools at HAARP provide hands-on training for graduate students. It's an open-air laboratory for grad students. Guys, this is really, really diabolical because I was able, and I hate that I have to go look all this stuff up, but at one point I found a Google book that had been indexed that it talked about some of the old school studies that they were doing with the plasma layer and the upper air 1950s and 60s nuclear explosions that they have been doing that then put out high energy particulates into the ionosphere that then they discovered propagated radio communications to be used by the Department of Defense. Guys, this all is tied to some of the very same technologies we've spent a lot of time looking at, and now with this whole new funnel of cash going into energy weapons, it's going to make you wonder. So, all right, I'm going to jump to a study that I found on Tuesday titled Climate Change in the Upper Atmosphere. And this really kind of gives a little bit of credence to some of the things that I've been saying, where some of this mad science ionosphere laboratory that they are working on right now could be attributing to some of this quote-unquote climate change that they're making millions on and trying to blame on you and me and the cows and little Johnny. Climate Change in the Upper Atmosphere by Ingrid Kosen from the High Altitude Observatory National Center for Atmospheric Research, USA. It doesn't say it's in Alaska, but I kind of guess maybe it could have been. Studies of climate change traditionally focus on long-term changes taking place in the troposphere. This is understandable, as this is the part of the atmosphere that most directly affects life on the surface of Earth. However, long-term trends higher in the atmosphere can have important consequences as well. In the middle and upper atmosphere consists of the stratosphere, the mesosphere, and the thermosphere, as well as the embedded ionosphere, which is the ionized part of the upper atmosphere. And that is also the same layer that gets excited when we have things such as solar storms. Many satellites operate within the thermosphere, and since the drag exerted upon them is proportional to the ambient atmospheric density, long-term changes in the density in the thermosphere can affect their trajectories and orbital lifetimes. So remember back a few years ago when we had quite a number of satellites or large telescopes with heat-treated glass that were coming out of orbit and becoming trajectories. No, what do they call them? Burning, flying, potentially, I don't remember the word. What's it called when you have some item that's burning towards you as a rocket would? But it had thermal stable glass in it. Remember that optical telescope that could land anywhere, and it was coming down out of orbit. It's got to make you wonder. That could be with all that space junk up there. Remember, DARPA has little robots, and they are actually hiring for people to go up there and find ways to save the space junk. It's got to make you wonder if that couldn't potentially be something in the future that they use to put us all into caves and scare us underground. Look out, here comes all the space junk. We don't know where it's going to land, but it could hit you. I don't know, I'm just being silly. Anyway, there is thus a possibility that long-term trends in the upper atmosphere could play a role in the tropospheric climate too, and for these reasons, it is important to gain a good understanding of the processes that cause long-term trends in this part of the atmosphere. As in the lower atmosphere, the increase in carbon dioxide, is thought to be one of the main causes for climate change in the upper atmosphere. However, it has become clear in recent years that several other mechanisms for long-term change must be considered as well. Ding-a-ling. So look at that. There are 2 studies now that are saying, no, well, carbon dioxide isn't really the problem, though that is what they're trying to stuff down all of your throats so they can make bazillions by sucking it out and turning it into something more useful to their pocketbooks than just feeding plants. And remember, those plants also contribute to climate change. So we don't need them anyway. It's just the most ridiculous thing I've ever heard. And we just buy it. We just buy it. I bet you 90% of the greenies out there are going to tell you it's all carbon dioxide. Put on your thinking caps, people. Put on your biology and your Eco-Science 101 from grade school and start thinking about this. These include changes in ozone, methane, and water vapor concentration, the secular variations of the Earth's magnetic field, and the long-term changes in solar, and geomagnetic activity. Also, climate change in the lower atmosphere could have an effect as well. The aim of this chapter is to review our current knowledge of the processes mentioned above and the role and cause of climate change in the upper atmosphere. A brief overview of the observed trends in several variables is given, followed by a discussion of the possible responsible mechanisms and estimates of trends caused by the mechanisms as determined from model simulations as compared to observed trends where possible. This is kind of a long document, so I am not going to read the whole damn thing, but I highly recommend that if you have any inkling as to the bullshit they're feeding you, that you read about this, because this will open your eyes. So let's read a little bit more, because I really think that it has a lot to do with this ionospheric heating, some of the other stuff that they're doing. So when talking about climate change, we generally refer to quasi-linear changes or trends that occur over a period of approximately 30 or more years. And that is a definition of the World Meteorological Organization. But in practice, climate change is not necessarily linear, and trends can and eventually will change over time. However, for the purpose of this chapter, we will assume that trends that have been observed over the last 50 or 60 years and subsets of that time frame can be meaningfully described in terms of linear change per decade. To measure trends, we need high-quality, long-term data sets, which are much sparser in the upper atmosphere than they are in the troposphere. In addition, The upper atmosphere is strongly influenced by what? Oh, the 11-year solar cycle. Oh, well, imagine that, as well as fluctuations in our geomagnetic activity. The shorter-term variability must be corrected for to be able to detect a long-term trend. And various studies have shown that this is not a non-trivial task and that different methodologies may yield different results. And residual solar signals can remain, especially if the data set is not sufficiently long. And remember, it took a climate scientist with 6 degrees to do a good study. Trends in the height of the peak of electron density of the ionosphere suffer from an additional complication when the ionospheric data are used. In that case, there is one measure, which is HMF2 is not directly measured, but calculated from the M3000F2 parameter, which is a transmission factor related to the highest frequency that can be propagated between two sites 3,000 kilometers apart by ionospheric propagation alone. These are differential empirical formulas used, and unfortunately these can result in different trends from the same data set, sometimes even with a different sign. But when incoherent scattered data are used, HMF2 can be directly measured, and this doesn't matter to us. But despite these difficulties, considerable progress has been made in building a global picture of long-term trends in the upper atmosphere. And in this chapter, we'll focus on a few selected variables for which both observational and theoretical trend estimates are available so that the two can be directly compared. These are temperature, density, and the critical frequency of the F2 layer, which is directly related to the peak electron density. So there's all kinds of charts, and there's all kinds of temperatures. There's all kinds of densities. Now let's look at 2.4 here, ionospheric trends. Another consequence of the atmospheric contraction as a result of global cooling, ding, 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 ding. So are they talking about global cooling? Is that ionospheric layers are expected to move downward as they trend to stay on the same pressure level. But on the other hand, ion electron densities should not be affected much as a result of global cooling, and as both ion production rates and recombination coefficients are expected to be affected in a similar way. Any increase in ion production could therefore be most offset by a similar increase in ion loss. Still, both long-term changes in the height of atmospheric layers and their critical frequencies have been found. Trends in the F2 layer vary strongly with location, season, and local time. And this is a trend that is derived from over 50 ionospheric stations. However, local trends tend to be much stronger and can either be positive or negative. Some studies have found regional patterns in F2 layer trends, but where's the nitty-gritty of all this? They also talk about ozone and its ability to absorb ultraviolet, and that's the UVC that we were talking about. If you have ozone holes, UVC could potentially get through, and that then would penetrate the water, which then could start melting that permafrost down at the bottom of the Arctic oceans, which then could potentially release high quantities of methane with methane mass expulsions, which would then contribute to climate change. So I don't know, guys. This is giving me a headache. Changes in solar and geomagnetic activity. Solar levels vary, blah, 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 blah. So where does this take us? Well, this takes us to the point that climate change is not CO2, that they are working on all kinds of atmospheric research in the ionosphere, making the ionosphere an actual laboratory up in Alaska and many other locations, and that it potentially could have some sort of effect by stimulating the ionosphere. Back to the end of that HAARP doc from DARPA. The HAARP facility has always been under the wing of the Department of Defense, so don't let them fool you. With participation and funding by DARPA, the Air Force Research Laboratory, the Office of Naval Research. It also got Port Bureau funding through Alaskan Senator Ted Stevens. That Genesis got HAARP off the ground and also likely landed it in its current difficulties. The NRC states that, quote, some participants at the workshop cited the unusual history of the HAARP facility as a contributor to its underutilization by the broader community of researchers. So otherwise, people were afraid of it. I kept holding up the NRC report saying that this is the scientific community talking. We have made our case that this is not an Air Force question. It is a national question, and McCoy says that the Air Force will likely pull the plug this summer, although parts of the service continue to do research related to ionospheric heating. But NASA and the National Science Foundation are sympathetic. McCoy is aiming for a pay-per-use model that will cost $6,000 per hour. But for a typical 2-week campaign running 12 hours a day, that amounts to selling about $1 million of time to each agency, he says. And Japan, Russia, and Sweden have also expressed interest in buying time at HAARP. So we're actually going to sell some HAARP time to Russia. Come on. So, I don't know, guys. Really isn't going anywhere except that I wanted to point out the fact that the CO2 thing is not what it seems. So where do we go from here? Well, we talked on Tuesday about up in Oregon, they have CRISPR'd some of the very first embryos that we know about, they say, in the U.S. This whole DNA thing, it's really got to be worrying. They can splice and dice all kinds of different life now. They're working on creating human-animal hybrids in the lab, all in the name of making organs that they can transplant. But they also have the ability to watch replication at levels we never thought possible. There was a story the other day out of ScienceAlert.com. DNA replication has been filmed for the very first time, and whoops, it's not what we expected, which undermines a great deal of what is already in the textbooks. Here's proof of how far we've come in science, or how far we've moved along that timeline of the destruction of life as we know it. In a world's first, researchers have recorded up-close footage of a single DNA molecule replicating itself so we can copy what it's doing at some point in the future. It is raising questions about how we assumed this process played out. The real-time footage has revealed that this fundamental process of life incorporates an unexpected amount of randomness that could force a major rethink into how genetic replication occurs without mutation. It is a real paradigm shift, and it undermines a great deal of what is in the textbook, says one of the team, Stephen Koslowski of the University of California, Davis, where they are doing a lot of research on cloning and things of that nature. It is a different way of thinking about replication that raises new questions, he says. The double DNA helix consists of 2 intertwining strands of genetic material made up of 4 different bases, and that would be CATG. Replication occurs when an enzyme called helicase unwinds and unzips the double helix into 2 different strands. A second enzyme called a primase attaches a primer to each of these unraveled strands, and a third enzyme called DNA polymerase attaches at this primer and adds additional bases that form a whole new double helix. The fact that double helices are formed from 2 strands running in opposite directions means that one of these strands is known as the leading strand, or that would be the guide, which I'm going to add, which is kind of how they're doing CRISPR, which then winds around the first, and the other is a lagging strand, which follows the leader. The new genetic material that is attached to each one during the replication process is an exact match to that what was on its original partner. Scientists have long assumed that the DNA polymerase on the leading and the lagging strands somehow coordinated with each other through the replication process so that one does not get ahead of the other during the unraveling process and cause mutations. But this new footage reveals that there is no coordination play at all, that it all is just random, and they act somehow independently of each other and still result in a perfect match each time. So, pretty frightening that they're doing all kinds of zipping and unzipping, but they've had it all wrong from the very beginning. Well, the team extracted single DNA molecules from E. coli and inserted them on a slide glass. Then they applied a dye that would stick to a completed double helix, but not a single strand, which would mean they could follow the progress of one double helix as it formed two new double helices. So while the bacteria DNA and the human DNA are different, they both use the same replication process, so the footage can reveal a lot about what is going on in our own bodies and why we might have 1,500 off-target effects of CRISPRing. We don't quite understand what we're doing, but step right up, because the gene editors are only getting started, says Jennifer Doudna, who is one of the creators of CRISPR, in an interview. Rewriting the code of life has never been so easy. In 2012, scientists demonstrated a new DNA editing technique called CRISPR, and 5 years later, it is being used to cure mice with HIV and hemophilia, and geneticists are engineering pigs to make them suitable as human organ donors, and that would be Georgie Porgy Church. And Bill Gates is spending $75 million to endow a few mosquitoes which spread malaria with a sort of genetic time bomb that could wipe them out as a species, and that would be the gene drive. A team at Harvard plans to edit 1.5 million letters of elephant DNA to resurrect the woolly mammoth, and that would also include Georgie Porgy Church. And I saw a special the other day on Travel Channel. It would also include a team in South Korea. Jennifer Doudna says, I have frankly been flabbergasted at the pace of this field. And she runs a lab at University of Berkeley. We are barely 5 years out, and it is already in clinical trials for cancer. So look out, guys, because now DARPA is jumping in the game and looking at ways to make it safer. All right, make sure you stick around, and I will try to be back tomorrow.